Hey everybody. In class today we worked on solving one-step and two-step equations. Tonight we're going to actually see how we can use those equations to solve word problems. In our first example here, we have a situation from the Olympics in 2004. You guys all remember that, right? In the 2004 Olympics, Sean Crawford won the 200-meter dash. His winning time was 19.79 seconds. Find his average speed to the nearest tenth of a meter per second. So I'm going to use the star process that we've practiced before to break down this word problem. First thing I'm going to do is underline what I'm looking for. Okay? Remember, that's the S in star. Stands for study the problem. So that's the most important thing, is what are we actually looking for? Find the average speed. So I'm going to use a variable to represent that. Average speed, we can use A. And I'm going to make sure I say what that represents. A is the average speed. Now I want to make sure I put a box around the important information. So I'm looking for the speed. I know I'm going to need to know how far he traveled. Let's put a box around that information. And I want to know how much time it took him, because that's going to be important to find the speed too. Now, what I don't need to know that he won. I don't need to see that part, his winning time. I don't need to know that it was 2004. And honestly, to solve this problem, it doesn't even matter what his name is. So now that I've completed my S step, I've studied the problem, I can go on to T. I can translate it into a mathematical statement. I know that if I multiply the time that it took him to run by his speed, that will give me the total distance that he traveled. And now I have a one-step equation. I can just divide both sides here by 19.79. And now, over here, this cancels, that equals 1. I'm left with 1a equals. And now I'm going to use some quick mental math to do this division. Definitely not using a calculator. We're going to get 10.1061142, but our problem says to round to the nearest tenth of a meter. So nearest tenth is right here. Look at that 0. And that tells us that our nearest tenth is going to be 10.1 meters per second. Let's check out another one. Here I have a scuba diving situation. As a scuba diver descends into deeper water, the pressure of the water on the diver's body steadily increases. The pressure at the surface of the water is 2,117 pounds per square foot. The pressure increases at a rate of 64 pounds per square foot for each foot the diver descends. Find the depth at which a diver experiences a pressure of 8,517 pounds per square foot. Alright, there's a lot of stuff in here, so I'm going to make sure I use my star process. Find the depth. That's what I'm looking for. Find the depth at which a diver experiences a pressure of 8,517 pounds per square foot. So that's what I'm looking for, the depth. I'm going to pick a variable. I'm going to say D represents my depth here. Now, important information. I know the pressure at the surface of the water is 2,117. That's going to be important, and it's important to know that that's the pressure at the surface of the water, because the pressure changes. It increases. This is another piece right here. It increases at a rate of 64 pounds per foot that the diver descends. So I got two big pieces of information right there, and I can eliminate this information up here because it's not helping me solve this problem. So now I can translate, I can do the T-step. I know that 8,517 is my final pressure, right? That's where we're actually looking for what the depth is. And I know that's going to be equal to what the pressure started at plus 64 times the depth because it's 64 pounds per square foot for each foot the diver descends, and that's represented by D. So now that I have my equation, I can subtract 2117 on both sides, do my inverse operation. Now, here we're going to cancel, and I'm going to have to do some subtraction here. That's going to give me 0. 1 minus 1 is 0. 5 minus 1 is 4, and we get 6 equals 64D. So 6,400 equals 64D. Got one last inverse operation to do. I'm going to divide, and D equals 6,400 divided by 64 gives me 100. So at a depth of 100 feet is where the pressure will be 8,517 pounds per square foot. All right, last example, I promise. Let's take a look at a job situation. Kim has a job where she makes $8 per hour plus tips. Yesterday, Kim made $53, $13 of which was from tips. How many hours did she work? Let's just underline that last part right away. How many hours did she work? Let's use a variable. I'm going to go with H, and we'll use that to represent the hours she worked. Now, I know she has a job. She makes $8 per hour, and we know she made $53. That's the total. And 13 of the dollars was from tips. Okay, I'm going to just cross out this little first phrase here. And it doesn't matter when this happened. And we have our information here. We can write our equation. I know the total was 53. That's how much she made. If she makes $8 per hour, I'm going to need to multiply that by the number of hours that she worked. And that's going to tell us how much she made from her wages. And then we have to add the tips. So I have a two-step equation here. I'm going to use my inverse operations. I'm going to subtract 13. 53 minus 13 gives me 40 equals 8H. Inverse of multiplication is division. And I get H equals 5. So if she made $53, that means she worked for 5 hours. All right. I think 3 examples is good enough. Make sure you complete the rest of your notes. Don't forget to submit, and I will see you all tomorrow. Have a good night.